So today, like I said, we're still looking at derivatives. Derivatives is something we'll be continuing to look at probably for the rest of the semester. Okay, because derivatives is one of the big things we're looking at this year, this part of this class. Okay, so slowly we've learned rules. We've learned power rule. We've learned product rule. We've learned quotient rule. Those are the basic rules. Now today we're going to learn how to take derivatives of trig functions. Okay, trig functions, sine, cosine, tangent, cotangent, cosecant, secant. Okay, so what we're going to do is that's what we're gonna go over today. We're just going to look at trig functions today. Okay, so the first example is they want us to find the limit of sine, or sorry, not the limit, the derivative of sine. So you can see that if I graph sine, it's a sine wave. Okay, it's a sine wave. That's one full rotation or one full cycle through the sine wave. It continues after that. So it starts at 0, goes up, comes back down through 0, goes to the negatives, comes back up at 2 pi. And then it continues, does the same thing for another 2 pi. Then it does the same thing for another 2 pi. It keeps doing that, right? So what we're going to do is we're going to find the derivative of sine. Okay. So what we find derivative. So when I talk about derivative, what am I looking for? What things go with derivative? What things go with derivative? When I say the word derivative, what should be popping in your head by now? Every single time I say the word derivative, what should be popping in the back of your head? You fresh? Slope, definitely slope. Good. That's one of them. When you hear derivative, you should always hear some sort of slope. Good. What else? There you go. So slope of the tangent line. There you go, right there, right? So a tangent line is a line that hits the function at one spot, kind of ricochets, right? What is the slope of that line? That's derivative. Okay, so what we're going to do is we're going to do that at each point. You see, we're going to fill out this table here that's going to tell us the derivative at each of those points there. Okay, so now we need to find the slope of the tangent line at 0. Okay, so let's go to 0 when x is 0 on the graph. When x is 0 on the graph. Okay, so that's right here. Right, this is the x-axis. 0 here. So at this point, use a different color so we can see a little better. At this point here, the slope of the tangent line would have to be something like this. Okay. So what is the, actually, more like that. What is the slope of that red line? What is the slope of that red line? We did this, what did we do this Friday? We were talking about slopes of lines. What is the slope of that red line? It's linear. Okay. So what's the actual slope? When you think of slope, you think of derivative, right? But even think of behind, like back, think of back slope. What goes with you in slope? Rise over run, right? Especially if you're looking at a graph, rise over run. So what is the rise over run of this guy? What is the rise over run of this red line? -12? Is that it? Not even close, right? Peyton, was it 1, +1, right? +1. How do we know that? We go up 1 Up 1 unit right there. From there to there is 1 whole unit. And then we go over 1 unit, right? Up 1 over 1, rise over run, it's going to be +1. So let's go put a +1 down in our table. Is there anywhere else where the slope of the tangent line would be exactly the same? So look throughout the dotted graph, the slope, the curve, the sine wave. Is there anything else, anywhere else where I would have the same exact slope of the tangent line? Anywhere else along the cycle? There's at least one other place where I would have that slope. Look at it, see if you can tell. Where else? You rush? Say it again. Past 5. So right here. Close, you're getting closer. Where? 2 pi. Yeah, look at 2 pi. Right at 2 pi. If you look at 2 pi, the slope of the tangent line is going to be it's going to be parallel to that line we just drew at 2 pi. So at 2 pi, let's write another one. Okay. All right. So the easier spots are to find where the slope is 0. What does a 0 slope look like? First of all, with your hand or your arm, what does a 0 slope look like? One slope looks like that, right? Looks like that. What does a 0 slope look like? Yep, flat, just like that, flat, right? So where on here, the dotted line, would I have a 0 slope? Or if I made a dot, the tangent line would be like this. Where on the X would that be? Let's see here. Pi divided by 2 is right there. 3 pi divided by 2 is right there. So let's see, let's draw another red line to see if it's like that, right? Yep, that looks pretty good right there. That looks like it's a, oops. Pi divided by 2. And 3 pi divided by 2. So at pi divided by 2, we have a 0. At 3 pi divided by 2, we also have a 0. Okay, so we're getting closer to filling it in. Now, is there anywhere else along the X that has similar to the red lines that we've drawn before? Maybe not exactly the same, maybe not +1, maybe not 0, but close to it. Is there anywhere else on the X-axis, anywhere else along here that, so it's not going to be +1, it's not going to be negative, it's not going to be +1, it's not going to be 0, but close to. At pi. Yeah, pi, what is the slope there, Yurush? It's actually the opposite of the ones we did earlier. It's a -1, right? If I draw this correctly. Oops. It's actually -1 there, yeah. -1. Okay. So I've gotten 5 of them. Okay, there's about 4, 1, 2, 3, 4 that I haven't. Well, it'll at least give us a good picture. Okay, so what we're going to do is we're going to graph these ones that I have right now on top of the previous graph. Okay, so I'm going to erase some of these lines from earlier because I don't need them. Okay, So I'm going to graph. I'll graph in red. Make dots here. 0, 1. So at 0, 1, I'm going to make a dot. At pi over 2, I'm going to make another dot. Oops, wait. That's not 0, 1. That's 0, 0. 0, 1's right there. Sorry. 0, 1's right there. And then I'm going to skip pi over 4 because I don't have anything for that. But I do have something for pi over 2. At pi over 2, I have 0. So let me go make a dot at 0. Okay, at 3 pi over 4, I don't have anything. But at pi, I have -1. Okay. 5 pi over 4, I don't have anything. But at 3 pi over 2, I have another 0. And at 2 pi, I have a +1. Okay. What are those? So kind of use your imagination. What are those red lines going to do if I were to connect them? Yeah, it's going to make, look at the one right below it. On mine, it's right below it. I don't know where you guys are. Look at that graph right there. That's the cosine graph. That's the cosine wave. Very similar to the sine wave, but it starts at a different spot, right? So now if I were to connect all of the red dots, it would do that. That's what it would do. So the dotted line is the original f of x. So what is the derivative then? The derivative is going to be, what's the derivative going to be? Cosine of x. So the derivative of sine is cosine. Okay, so the derivative of sine is cosine. So anytime you see a derivative of sine, that is cosine. Okay, so what is the derivative of cosine then? Have maybe something to do with sine? Well, let's find out. Let's find out right now. Let's do the one down here. So on this, let's find derivatives. Derivatives of, so where are there any places on here where I would have a zero derivative? A zero derivative, just like I did above. Are there any places on here I would have a zero derivative? Look on the cosine wave. Anywhere where I would have a zero. There's a few places, maybe more. As well. At x. Pi, there you go. Yep, pi, you're right, that is one. Right there. Right there, I would have a derivative of 0. Okay, so let's write that in our table. Oops, not 1, 0. Anywhere else on there would I have a derivative of 0? Slope of the tangent line being 0.
0
there you go. There are the other spots right here. 0 kind of tops out right there. So we're looking for the peaks and the valleys. If there's a maximum or minimum, that's where I'm looking for. Okay. Okay. All right. Any +1 or -1s? Any +1 or -1s like we saw in the last one? Any derivatives that would be +1 or -1? Go ahead. No, go ahead, Daniel. Pi over 2. Let's see. Pi over 2. Yeah, it looks like pi over 2. I would have a -1. All right, a -1. And then where else would I have a +1 or -1? 3 pi over 2, yeah. That one would be a +1. So again, I didn't fill out everything in the table, but I got enough. I have enough to give me a picture of what it's going to look like. Okay, so let's graph those points and see what the picture looks like. We think it might be sine. Let's see. Only one way to find out. So let's see. So 0, 0. Pi over 2, -1. Pi 0. 3 pi over 2. 1. And then 2 pi 0. Okay, so before we actually connect the dots with your head. Will that line up to be the sine picture we saw at the beginning? It is similar, right? It is similar. But instead of going up to start out, we go out. For sine, right? We go up, down, over. For this guy, it looks like we're going to go down, up, over, right? 1 second.
Yes, I do, but she's absent today. Yes. Yes. Sure.
Okay, so it kind of has the same features, right? Except, would you say earlier, Isabella? It has the same features as sine, except it's going the opposite way, right? So instead of positive sine, let's finish drawing. Let me finish just drawing this guy. Oops. It's going the opposite direction, right? So if I compare it with the original sine, when sine goes up, this one goes down. When this one goes up, sine goes down, right? So it's kind of doing the opposite. So the derivative of cosine is negative sine, or -1 times sine. Means the opposite, right? If sine's going up, this one's going down. If this one's going down, sine's going up. Okay, so it's kind of like so if we start with sine here. What's the derivative of sine? Okay, cosine. What's the derivative of cosine? Negative sine. Here's a question. What's the derivative of negative sine? Negative cosine, right? Because isn't this really just -1 times sine? That's just the coefficient, right? So we know the answer to we know that the derivative of cosine, or sorry, the derivative of sine is cosine. So let's do the derivative and then multiply the -1 again. What's the derivative of negative cosine? What's the derivative of negative cosine? We know the derivative of cosine, so do the derivative of cosine and then just add a negative. What is it? It's a wheel. Okay, sine and cosine, derivatives of sine and cosine are a wheel. It's a revolving wheel. So we have sine of x, cosine of x, negative sine of x, negative cosine of x, back to sine of x. So anytime you see a cosine or a regular sine, you should know exactly what the derivative is going to be, because it's just a wheel, just a rotating wheel. Okay. Okay, so I could do that for every other one. I could do that for tangent. I could do that for cosecant. I could do that for secant. But just for lack of time, I'm going to give you the rest of them. So here are the rest of the derivatives. So we did the first two. Okay. Sine, so derivative of sine is cosine, derivative of cosine is negative sine. The derivative of tangent, the derivative of tangent is secant squared, or secant of x squared. So secant of x times secant of x. The derivative of cotangent is negative cosecant squared. Negative cosecant squared. The derivative of secant is secant itself times tangent. And then the derivative of cosecant is negative cosecant times cotangent. Now I could do what I just did up here with all of those to prove it. But like I said, for sake of time, I'm not going to do all of those, but you could to prove why it's that. Okay. So what we will do is prove the derivative of tangent is secant squared. Okay. So we're going to prove the derivative is secant squared. Okay. So tangent of x. If I was to find tangent of a triangle or on the unit circle, how would I do that? How would I find tangent on the unit circle? What would I have to do? Or just a regular triangle? Exactly, y over x, right? So let me draw a triangle right here. So if I have a triangle, that's my angle there. It's going to be y over x, right? Opposite over adjacent for tangent. So tangent, let me write this down, is y over x. What is sine? If I wanted to do sine on the same thing, what is sine? Y over 1, or just y, right? Let me change these to theta. So we don't get the x's and y's. Y over 1, right? And if I wanted to find cosine, what is that? X over 1 or x, right? So is it tangent a mixture, a combination of sine and cosine? Right? Y over 1 is just y. X over 1 is just x. So isn't tangent just y over x, which is the same thing as sine over cosine? Right? So I can rewrite as sine of theta over cosine of theta, right? So what's the derivative of that? So how am I going to find the derivative of that? How am I going to find the derivative of that? Yeah, Donnie? No, not that. You're close. You're close. I like the way you're thinking, but a little. You've seen it before. Or if you haven't seen it before, I can give you another quiz right now and you'll see it again. Thank you. There you go. Quotient rule. If we're finding derivative of this, isn't that quotient rules? Don't worry, we'll have a test coming up here pretty soon and you'll see it again. Okay. Anytime you have that and you're finding derivative, that's a quotient rule, right? That's what I'm going to do. I'm going to find the quotient rule. Okay. So instead of tangent, I'm going to use this guy here. So quotient rule, which you guys did on your quiz last week, is low. Or I'm going to change it to X and Y so it doesn't, instead of theta, since we're done with the X's and Y's. Low times the derivative of high. Well, what's the derivative of sine? We just learned that. What's the derivative of sine? Cosine minus high d low, derivative of the low. What's the derivative of cosine? We just learned that. If you're not sure, look at my wheel over there, which you should have on your paper somewhere. Negative sine, or -1 times sine. Okay, over bottom squared. All right, so let's clean this up. So we have cosine squared, and then I have two negatives here, which I can make a positive. So plus sine squared of x over cosine squared of x. Okay. What would, anyone know what that equals? Does this look familiar to anybody? Has to do with triangles on the unit circle. It's 1, yeah, it is 1. Yeah, Sebastian, do you remember why it's 1? No, but you know it's 1. It's good that you recognize it. It's good. It has to do with the squared. It has to do with the unit circle. Yeah, I'm glad you remember it's 1. More so than why, but I'll show you why. I'll just remind you guys why. So if you, let me do it on here so it can record. So if you have the unit circle, right? So, if you have the unit circle, four quadrants, and then let's say you have an angle here. The angle here, right? Well, we said this is y. We know this is y right here, and this is x down here, right? And this is r, which is usually on the unit circle is always 1, right? So this is a right triangle. All the triangles in the unit circle are right triangles, right? So what is the theorem that goes with right triangles? Pythagorean theorem, right? And Pythagorean theorem said a squared plus b squared equals c squared, right? Well, we didn't use, on the unit circle, we didn't use a's and b's, right? We use x and y. And then this guy over here was just the radius, right? So the radius was always 1. 1 squared is still 1. And then what did we say was x and y? We said that earlier on the unit circle. X was the same thing as cosine, right? X was cosine, X over 1 cosine. Sine was Y over 1, right? So what we did was we said, okay, so cosine, if cosine is X, let me plug it in there. And if sine was Y, let me plug it in there. You just replaced them, right? You just substituted them. So now cosine of X squared plus sine of X squared equals 1. That's the relationship we just saw. All right, that's the relationship we just saw on the numerator, in the numerator. Okay. It's an identity. It's called the Pythagorean identity. Okay. So we know, so because of that, the top is going to be 1. The bottom's still cosine squared though. Well, what does cosine square simplify to? Or what is 1 over cosine? Secant. The way I remember it, this is the way I remember it. Sine, like sine over X equal, or wait, sine over X goes with cosecant, and cosine goes with secant. So this is the way I remember it. Sine of X goes with cosecant, cosecant goes with secant, S goes with C, C goes with S. So S's don't go together, C's don't go together. Okay, so if you're looking for the reciprocal of sine, it's not going to be secant because S's don't go together. So what's the other one? Cosecant. Same thing with cosine. If you're looking for the reciprocal of cosine, it goes with secant because C's don't go together. That's the way I remember it. Okay. So we're going to change this guy over here. Since this is a reciprocal of sine squared, we're going to change it to secant squared. So that's why the derivative of tangent equals secant squared. Now you can do that with every single one of them. You can do that, like I said, you can do that with this entire box and it would work. I'm not going to take the time to do it. Okay. So people ask me, do I have to memorize these? And I'm like, no, you don't. I didn't memorize that tangent was secant squared, right? I proved it here. Now, I don't think you want to prove it for every single one. So it's probably easier to memorize them than to do this. Okay. So the question is, do you have to memorize them? I always say no. Well, then how do I do it? Look at example 2, right? I don't think anyone wants to do that though every single time, right? So it might be a little easier to actually memorize them. Okay. And the nice thing is, or not so nice, we're going to be using these a lot. We're going to be using these a lot throughout the whole year. So you're going to be using them quite a bit. Okay. So even if you try not to memorize them, they'll probably still stick in your head. At least some of them. Cosine, sine, cosine, tangent, secant we use a lot. Okay. That wheel for sure should stick in your head. That wheel should for sure. The sine and cosine derivative wheel, because we use it a lot. Those are the ones we use a lot, sine and cosine, but you will see others. Okay. Okay, so let's jump back into this guy here. Number 4. Skip number 3. There was no number 3, so we'll just go right to number 4. All right. Okay. If we're finding derivatives, right, we got to find derivative. Take a big guess as to what we're going to do. Take a big guess as to what our first step is going to be. Exactly the product rule. Why do we use the product rule on this one? Anytime I have two functions multiplying times each other, and I have to find the derivative of them, that's the definition of using the product rule. Now, if this guy was instead, if it was like this, four times sine of x, would I have to use the product rule here? No, because that's not a function. It's just a coefficient. It's a coefficient in the front. You could use the product rule. It wouldn't be wrong, but it's just steps that you don't have to take. For this guy here, you would just say, okay, so it's just going to be, let's move the 4 to the side. Find the derivative of sine, which is cosine, and you're done. We can't do that with the one we're looking at because it's two functions multiplied times each other. So we have to use the product rule. Okay. So the product rule says, the first times the derivative of the second, and then plus the opposite. Okay, so the first one is x squared. So we got x squared there. Times the derivative of the second. What's the derivative of the second? Cosine, it's right on the wheel. Plus the derivative of the first, which is 2x, times the first, or sorry, the second. Fine. So I have x squared times cosine of x plus 2x times sine of x. You can't really reduce that. There's no really way to combine them because one's cosine of x and one's sine of x. So there's really no way to do anything. Done. Okay. All right. Okay, so try this one. I want you to try this one on your own. Try letter B on your own. Give you about 5 minutes to do that. Okay, so derivative of something divided by something, that's a quotient rule. Okay, so the quotient rule, let me just write this down here, says low times the derivative of the high. So the derivative of the high is negative sine minus high times the derivative of the low, which is just 1, over low squared. So we got negative x sine of x minus cosine of x over x squared. Can I cancel some x's? I see a lot of x's. I see 4 of them. No, I see 5 of them. I see an x here. I see an x here. I see an x here. I see 2 of them down here. So can I cancel some of them? The answer is yes, if you want to lose points. If you want to get full credit, no. Why can't I do that? Why can't I? Yeah, Isabel? Yeah, so this is the only one on top that possibly could. If there was one here, I could factor out an x. I can't factor out an x here. These x's here, they're angles that are part of the trig function. They're not x's that can be factored out. Okay, they're angles, sine of an angle, cosine of an angle. This guy over here could possibly be factored out, but I would need an x here to do that, and I don't have one. So because of that, I can't simplify any further. Okay. All right. Okay, so these guys here. Okay, so so we have root t plus secant of t. Okay, so we got to find the derivative. Well, again, if we're finding derivatives, I don't want roots. I want powers, because I don't have a root rule. I have a power rule. So t, I got to change to a power. So what am I going to change? What am I going to put there? T to the 1/2 plus secant of t. Sometimes you put it in parentheses. Sometimes they don't really put them in parentheses a lot, but I like to put them in parentheses just to show, hey, that's not a t like a regular t. That's an angle t. Okay, so I can't use that. I can't factor that guy out. Well, now it's just one function plus another function. That's just sum and difference rule. So let me find the derivative of the first one. So to find the derivative of the first one, I'm going to move the 1/2 to the front. So I get 1/2 t. I'm going to subtract 1, which leaves negative 1/2 plus secant of t. Well, I go to my list and I see that secant of t is secant x tangent x. Well, I didn't use x's on this one. I have t's. So I'm going to put secant of t times tangent of t. Okay, clean it up a little bit. Some of you guys on the quiz left it like that, would leave it like this. I didn't take away any points, but in the future I might. So this guy right here has got a negative exponent. So if it's got a negative exponent, you shouldn't leave your answers with negative exponents. Okay, so in order for me to make it a positive exponent, I'm going to have to do this. T over 2, oops, no. So 1/2, and then the t is the square root on the bottom, plus secant of t times tangent of t. Okay. Okay, so do letter D. Do letter D on your own. If the S's bug you, like if you don't like to see S's, change it to an X or a Y. Okay, just change it to an X or Y. It's the same thing. And then change it back at the end. So we have a few minutes left. So let me tell you what I did. So I changed it first. First thing I did is I changed the way it looks. So instead of 1 over S, S to the negative 1. And then minus 10 times. Okay, so this part right here, I don't have to use the product rule for this guy. I do not have to use the product rule because 10 is just a coefficient. It's 10 times something. So whatever I get, whatever the derivative is, I just multiply it times 10. So this is, and then I found the derivative here. Derivative of S to the negative 1, derivative of this guy here. Change so that I didn't have any negatives. Negative times a negative, made a positive down here. H prime of S equals. All right. Okay, so we'll finish up these notes tomorrow. We're going to finish up the notes. There's a couple things I want to go over, and then I'll give you time to start on the assignment. Okay, so I'm not going to assign anything new today. Tomorrow, like I said, we'll just finish, and you'll have time to do your assignment. Say it again. Consonant, because it's a coefficient, you mean? What do you mean? What do you mean get rid of it? I can't get rid of it. I just multiply. It's a coefficient, so I multiply it times whatever the derivative is of this. The derivative of this was this guy right here. That was the derivative. And so I multiply 10, negative 10 times that. There you go. Yep. So if you have a coefficient in front, just move it to the side and then bring it back in at the end and multiply it times whatever's there. Okay. So we'll go, like I said, we'll finish these notes tomorrow, and then I'll give you some time to work on the assignment in class that goes along with this. Okay. All right, let me post these notes.